We are moving on to Chapter 2, and Chapter 2 deals with polynomials that are bigger than quadratics. So a quadratic is an x squared, but polynomials can get infinitely large. So first, we have to decide, is something a polynomial or not? So an example of a polynomial would be f of x is equal to 6x to the 5th minus 7x to the 4th, and so on. Okay? Now notice, a polynomial is made up of terms, and those terms have numbers and variables with exponents. So the numbers in front of the variables are called coefficients. And coefficients can be any number. Okay? But polynomials are very strict on what their variables can look like. Okay? The variables have to have whole number exponents. Okay? And notice I have 5, 4, 3, 2, 1, and the last one has an exponent. It's just a 0, because anything to the 0 is 1. So here are the things that polynomials don't have. You'll never see x to the negative 3. That breaks the rule. Okay? Same with x to the 1/3, or x to the 2.4, or even 1 over x, or the square root of x. All of those things are against the rules when it comes to polynomials. So in this first problem, you just have to go through and list which ones are polynomials and which ones are not. So, is A a polynomial? Yes, it doesn't break any of the rules. It does have a variable, but that variable is x to the 0, which is still okay. What about B? Yes, that's fine. What about C? Well, can we put numbers in the denominator? Yes, we just can't put variables in the denominator. So C actually works. And D? No. You can't do square root of a variable. Okay. Now we have a polynomial that's kind of split into two parts, and it says solve for u. Well, this first one is already set up in factored form, but the next one we need to factor. So 2u minus 4 stays there. Are there two numbers that multiply to be negative 18 and add to be 3? U plus 6 and u minus 3. And if you need to use the box for that, go right ahead. Okay. Now, we write equals 0 on all three of these. So for the first one, I add 4, and then I divide by 2. And I get u is equal to 2. The second one, I subtract 6, and I get negative 6. The third one, I add 3, and I get 3. So the answer is 2, negative 6, and 3. You guys okay with that? Okay. Same thing here, but notice this one happens twice and this one happens twice. So my roots would be x is equal to, what's the root there? What number makes that 0? Nope, 0. Okay, and then this one is 2 and 2, because there are two copies of x minus 2. And then the last one is 9 and 9. But on this problem, it just says, tell me what the numbers are. So where does this graph hit the x-axis? And the answer is 0 and 2 and 9. But you're going to see in a future assignment that when a root happens 2 times or 3 times or 4 times, something weird happens on the graph. So there are problems in this assignment that ask you the question of what is that root's multiplicity? Multiplicity is a big word. It seems scary. It just means how many times did it happen? So on this problem here, it says list each zero according to its multiplicity. So you can't see it on this, but this is what it will say. So the multiplicity of 1. It wants to know which roots happened 1 time. And the answer would be 0. And then we'll have multiplicity of 2 and multiplicity of 3. That looks like a 3. So in this list, which roots happen twice? 2 and 9. And in that list, which roots happen 3 times? None of them. Okay? So in some problems, you just list the roots, and you don't need to worry about their multiplicities. But in number 4, it asks you what are the multiplicities. Okay. Number 5 wants us to go backwards. Number 5 says, if the roots are 0, -3, -8, and 1, then what is the equation? All we need to do is turn each one of these back into a factor. So what is the factor associated with the root x equals -3? It would be x plus 3. And this one would be x plus 8. And this one would be x minus 1. What about the 0? What would the factor be? No. If -3 got turned into x plus 3, what would 0 get turned into? You could do x plus 0. But what is x plus 0? It's just x. So really, all I need is an x. Okay? Well, what if 1 happened twice? How would that change my equation? You would just square that factor associated with that root. Okay? Okay, let's look at 6. Is A a polynomial? Yes, it obeys all the rules. Is B a polynomial? Can we have decimals? Not in the exponent. We can have decimals as coefficients, but the exponents cannot be decimals. So B is okay. What about C? Nope, we're not allowed to have variables in the denominator. And D? No, we can't take the square root of a variable. Okay. So this one we would factor w minus 7 and w plus 6. And then I would just write equals 0 on all of those and solve. We good there? Okay. What are the roots of number 8? How about that? W plus 1. Is that better? Sorry. Thank you. Okay. And here, x is -7. Ooh. This is a little bit tricky. What are the roots of x squared minus 4? So x minus 4 squared would be x equals 4 and 4. But x squared minus 4 is different. That is x minus 2 and x plus 2. So you got to be careful there. So the roots are -7, 2, -2, and 7. That was kind of tricky. They threw that in there. Okay, down on number 9. 3 of them have a single multiplicity, and 1 of them has a triple multiplicity, and none of them have a double multiplicity. Okay, any questions? Think you can handle that? All right, get to work.